to the Talking Serverless Podcast. I'm your host, Ryan Jones, joined today by Dr. Denis Bauer, CSIRO's Principal Research Scientist in Transformational Bioinformatics, Adjunct Associate Professor at Macquarie University, and AWS Data Hero. Dr. Bauer develops machine learning and cloud-based bioinformatics solutions that help fight emerging diseases like COVID-19. She is passionate about improving health by understanding the secrets in our genome, using cloud computing, while also building a strong community of practice through open source technology, keynote presentations, and inclusive interdisciplinary collaborations. How are you doing today, Deniss?
Hi, Ryan. Fantastic to be here with you today. Yeah, I'm really good.
Awesome. Yeah, no, this is very exciting. As we talked about right before we started, your background is somewhat different than the traditional podcast guests here on Talking Serverless. And so, I think that's going to be very exciting for both myself to learn more as well as our audience.
Yeah, fair enough. I mean, similarly for me, I've been going into this area quite new because of the necessity of the data that we're dealing with. So we were sort of thrust into this world of high IT, cutting edge technology, and we do need to find our way, feeling our way around it. So it's experts like your listeners who guide the research that we do.
Yeah, that's fantastic. So let's just jump in there. So when you're saying that kind of out of necessity getting into this, what kind of spawned that happening?
Yeah, so we started off with human genome research. And as you probably know, the human genome is quite large. It's 3 billion letters. And therefore, in order to analyze all of this, we do need to have a lot of compute crunch. And while typical research, large research institutions, they do have high performance compute clusters that can be used. And that's what we started off with. Processing one genome on a large cluster and reserving the time, waiting for it, dealing with a failure in there, reanalyzing the data because it failed again and again and again. And sort of from there, we thought, well, there must be a better way. And this is basically what Google has invented with the distributed computing and the MapReduce and Spark cluster approaches, where if there's something fails, it seamlessly picks up from there and starts over again. And this led us then down the Spark analysis route. But the problem back then was that Spark wasn't really available on your local high-performance compute cluster, which meant we had to rent a cluster in the cloud, and that was sort of our first forte into that area. But then we quickly realized that even that isn't enough, because the main issue there is that if you're renting these massive clusters, they don't simply go away. You have to pay for them, even though the researchers are sleeping and not using them. And again, we thought, well, there must be a better way. And this was in 2016 when Lambda first came out from AWS, which was basically the answer to all our to all our dreams, on saying we want to have compute that can scale up to these massive workflows. But if we're not using it, it simply goes away without having us to pay anything. And on a researcher budget, on a shoestring researcher budget, that is the ideal outcome.
Yeah, no, this is amazing. I did some machine learning work in 2017, and we had a similar thing happening where we had these super large servers that we needed to run, and they would be on all the time, and we'd be paying for that kind of idle usage, and then kind of use serverless and Lambda to kind of create almost dev environments where we could test our computer inference things, but then also have them turn off afterwards. And so it's kind of cool to hear how that developed. To dive more into how you even got to where you are, I think I butchered the introduction, to be honest. So when it comes to your own background, do you mind giving the listeners an idea for how you got into tech, how you got into serverless, how you got to CSIRO, and just what led you down this path?
Yeah. So I'm a researcher, and I guess as a researcher, you do have to have this rebellious streak to it that you want to find out more. You want to find out the meanings behind or challenge the status quo. So that's what I did ever since in school. And I then went on to university to study bioinformatics, which back then was a new discipline. The human genome was just sequenced back then. And it sort of opened up this whole new world of really measuring us quantitatively. Because as you probably know, a lot of disease risks are encoded in our genome. So therefore, understanding this really helps in tailoring treatments to a person or predicting what kind of risks they might have in the future and adjusting lifestyle changes where, simply eating healthier can curb your risk quite substantial rather than having to use drugs when it's too late. So with all this excitement and hype around the human genome, that was sort of the space that we were jumping into there. I was quite fortunate in doing a bioinformatics course with one of the people that actually sequenced the human genome. So he understood what is actually involved in terms of the compute crunch that is needed, down the track of analyzing this. So there was a heavy focus on the IT side of it. In fact, we were doing the IT courses with the people in IT. Similarly, with the medicine and the chemical people were sort of sitting in with future clinicians and future chemists and future biologists and listening into their individual talks, sort of giving us this humble understanding of the wealth of information that is involved in each of those disciplines. So with that education, I then came to Australia to do my research here. And eventually, sort of the biggest research institute here in Australia or organization is CSIRO, which is sort of the innovation hub or the collaboration hub between Australian industry and academia. And yeah, this is the place where I'm at now.
Oh, this is amazing. And something that was very fascinating hearing you talk about this is, had there been already any examples where this mapping of the genome and the way that you said that it can already have diseases and markers for that, has cloud computing and other things like that helped in these cases? Do you have any like cases where this has been already like a home run? And yeah.
Well, science or human health is a complicated field. Therefore, saying breakthroughs and home runs, it's never as trivial as that. But we did have insights into the human genome that weren't possible before. So my own research, for example, focuses on, can we develop machine learning methods that can take the entirety of the human genome into account when finding disease genes? So typically, when disease genes are researched, is you have a case control cohort. You have people that have the disease and you have people that don't have the disease. And then you're basically finding what is the difference in their genomes, like finding the needle in the haystack. Out of the 3 billion letters, which one is different? And that is the traditional approach of looking at each one of those locations independently and seeing if there's any enrichment in the disease cohort. But we do know that there's massive redundancy in the genome, where one gene is working together with another one. So if there is a mutation over here, this one might be able to compensate it. So really, to understand this whole area, you do need to look at the whole area. And that with the traditional approaches was not possible. But using machine learning, building random forests, we can look at the mutations over here, mutations over there, seeing whether they together fall into a tree and are discriminative in terms of the phenotype, in terms of the disease, and explaining the disease that comes out at the end. So yeah, we've been researching motor neuron disease mainly, which is a disease that Stephen Hawking suffered from. And there we did identify a couple of new areas that people have not looked at before that's implied in, or that there's an association with a disease and could be novel drug treatments going forward.
Oh, that's amazing. And one thing that I started thinking about is, I'd love to hear your perspective. Is where do you think we're headed? Because when you're talking about the machine learning, and I completely agree. If you have, as you said, 3 billion letters and all this stuff, and you have a traditional human reading that, that's almost impossible to see how those things develop. But if you're using, leveraging massive compute, and you're running all these different simulations, and you're seeing all how it's developing in real time, and then being able to cast those patterns across these, Where do you believe that this type of work is going to lead us to?
Ultimately, the idea is not only to understand the genome and then react to it, but be more proactive about it. So this is another research area that we're into called advanced therapeutics. So this involves gene therapy, genome editing, phage therapy, which combats antimicrobial resistance that are arising. And all of this really has the base to it that we do something to either our genome or the genome of the organisms that infect us in order to treat the disease that people have. And for that, the key element to safety is really to tailor it to the individual. And for that, when a patient comes in, there needs to be instantaneous analysis of basically all the medical data that are relevant for that person. And that, I would argue, really requires serverless, because if that is not a burstable workload, I don't know what is. So therefore, bringing in these resources from all over the world, probably, not only from this patient, but also referencing it from other patients that are similar from all around the world, and then computing over that, I think this is the holy grail where we're trying to get to.
Yeah, that's really cool to hear, and it sounds like a perfect use case. Yeah, and I think the burst for that would be quite intense. Can't even imagine. And one thing that yeah, I saw here was that last year you won the collaboration medal for CSIRO for your work analyzing the COVID genome. Do you want to talk about that and like what that meant and what it was for?
Yeah, for sure. So COVID, as we know, is a viral disease. And with all viral pathogens, they do tend to mutate, especially when they first are introduced into a new host organism, the human in that case. And way back then, where we hardly knew anything about the virus, the key question was, if we develop a vaccine, what are we developing the vaccine for or with? Like, what kind of strain of the mutation of the virus that mutates, and the individual mutation elements are called strains. So which one of those strains do we develop it against? So there were samples from all over the world, and the question was, which one is the one that probably will take off and take on the majority of the infections around the world, and which ones are weird outlier where the mutation that they accumulate are not going to take off. And for that, we developed a new machine learning method to do that. It basically took it split up the genome of the virus into small windows, and then it counted those windows and the content of that windows, and basically developed a fingerprint of each viral strain, so we could compare them to each other and see where they fall onto sort of an evolutionary landscape, where the distance between two strains is the evolutionary distance between them. And with that, we could then map them on this map and see where is basically the cluster, where do most of them fall into, because this is likely where the bulk of the virus infection will go from in the future. And here we developed a web service based on serverless that could do that on an ongoing basis. Because, yeah, we did it back then where we had 200 samples from around the world, but now we have almost 3 million samples available. And therefore, tracking where this virus is going and how it is evolving is absolutely crucial. And as you can imagine, the compute resources involved in doing this for 200 samples or 3 million samples is quite different.
Yeah, no, absolutely, and something that seems like a very hard problem as well. If it's mutating so many different ways and trying to identify that, I think this is correct me if I'm wrong here. I think that's probably why it's sometimes hard to almost why we need almost like an annual vaccine to some different diseases because they mutate so often. Do you think that is it possible to get to a point where we can kind of account for all those different variations and kind of create a vaccine that's like more widely covering all the different strains, or is that almost like not even possible?
I don't think we can predict that for the coronavirus, because there's hardly really anything known about it yet. But looking at other viral diseases, flu, for example, we do know that we have to have an annual update to the vaccine because it is mutating so much. The difference, though, between flu and coronavirus is that flu has a much more violent evolution, if you want. It basically can shuffle its whole genome around. It's called reassortment. And coronavirus does not seem to be doing that. Therefore, the mutation rate or the change over time that the coronavirus seems to be able to achieve is lower. That is promising in terms of coming up with something that does not have to be annually updated. But because this disease is so new, we don't know whether it's just picking up speed in order to come to that violent change in evolution, if you want, or whether it will stay stable. What we do know is that no one is safe until everyone is safe, because when the virus has the opportunity of continue spreading in an unvaccinated population, for example, it will pick up more mutation. It will pick up, it will explore the evolutionary space more effectively. And therefore, whatever super strain might come out of this melting pot of mutational capability will be then spreading all over the world and will be reinfecting even the vaccinated people if it has some escape mutations in there. And there's some evidence that this is actually happening. So, for example, the Delta strain, we do know that it's more infectious, meaning that it spreads easier between individuals. There is some evidence of mutation that make it more pathogenic, and there is evidence for mutations that make it escape from the vaccine. Because what the vaccine basically is, it is something that recognizes the spike protein of the virus, and if that spike protein changes enough so that our body can't recognize it anymore, then all the effort we put into vaccinating the population is for nothing, because our body does not recognize the virus anymore and treats it as if it was a new infection.
Yeah, wow, that's a very, very difficult problem, it sounds like. And so, yeah, when the pandemic started, and you're in the position that you were, how did your life change with all this stuff happening, and with your unique background?
I think we quite early on recognized the implication of all of this. And being a research organization, we were able to focus our effort then onto this massive global problem. So basically in 2020, we almost dropped everything and focused exclusively on COVID and finding the right vaccine strategy for it, or contributing to that. Which on one hand was scary because it was a new area. It was nothing that we've done before. There needed to be a lot of bespoke analysis that was required for that, and it was like our old research had to be put on hold. But on the other hand, it was very rewarding because suddenly you were working on something that universally everyone agrees that this is a priority area and needs to have a solution. So I think this was the first time where sort of the researchers were able to communicate with anyone on the street, and it was a topic that everyone found interesting. So I think that sort of brought the importance of science and the importance of research to mainstream, and that was quite an interesting and rewarding, I guess, experience.
Yeah, that was something else I was going to ask about, is that doing the type of work that you're doing, and now mixing in the cloud computing aspects and serverless, how, for those listening that have that type of background that maybe you've never considered applying that type of knowledge to the field that you work in, what would you kind of say to those people that maybe have never even thought that I could be doing serverless development in this similar field?
Yeah. So let's keeping the serverless as sort of the secondary question. Like, I talk a lot to IT people that come to me after the talks and saying, "Wow, the area that you work in, it's so immediate, it's so rewarding. You do see the outcome of what you're doing so immediately, rather than working on a commercial product or delivering something to a client. And I would argue that whatever the IT community has developed is basically the foundation that lets us, stand on the shoulders of these giants to come up with the research that we're doing. So basically, I would argue that everyone in IT has contributed one way or another to doing medical research and pushing this field forward. Be that, through GitHub repositories, be that to pushing open data, pushing the open software strategies. So all of this really has contributed one small step to the overall outcome. And with that, I would argue that anyone who wants to go into the field of medical science and medical research from the IT perspective could do that tomorrow. All it needs to take is this interest in life science, medical research, and the willingness to learn this area and bring the expertise from IT to that. So this is a general IT statement. In terms of serverless, I think this is even more pronounced there, because serverless is so new that basically everyone is new to that field. And we're all learning from scratch. We're all feeling our ways around it, and we're all pushing this paradigm forward together. So therefore, having as many experts from different disciplines, I think is really helpful, because not only can we bring our background to this and push the area, but it's also that we have all different ideas and different visions and different use cases for serverless. And I think this will create a richer environment going forward.
Yeah, very, very well said. And something else that this whole thing kind of plays into is in the type of work that you're doing, and recognizing the need of serverless and kind of acting on that. Is that widespread in this field, or is it more like it's very unique to specifically, I believe it's CSIRO?
Yeah. Difficult question. I think this is compounded by cloud in general. There is still somewhat a hesitancy of the medical community to go into the cloud, and this is around concerns around data privacy, having to give up the ownership of data. And I think there's only just now this understanding that keeping the data safe is easier in the cloud, because you do have the global community developing standards there, rather than having to rely on your local team to know everything and keep the data safe there. So I think with this paradigm shift of now having accepted that the cloud is likely to go, to be the way forward, the next question is around vendor login. Usually there is this problem with cloud going to the cloud of saying you're logged into that vendor and therefore you can't really commit to that. But with serverless, the idea is that yes, your data might be located on one, but your compute can be on another. And there's this interface between the two clouds potentially that make that seamless. And again, serverless really allows for that, because it has this idea of modularity built in, where each element can be located in a different service on a different server and a different provider, and is brought together by this notion of interfaces, APIs, and so on.
And so when it comes to potentially increasing the adoption of that, do you feel like that's just a natural process which is happening already, or are there other things that can happen to kind of accelerate that move? Maybe even this podcast, potentially you talking about this, is already helping in that. But are there other ways that kind of just almost informing the community that you are able to have data privacy and keep your data safe, and you're able to kind of move around vendor lock-in a little bit as well?
Yes, obviously, if you build together solutions, examples, then people will realize that this is not just theory. And to be fair, at this stage, it is just theory. We do need to push, I think, the providers as well to fully embrace the idea that you have to grow the pie together. And for that, you do need to have some sort of leakage between the different systems. and to not only cater for that, but to really build that into their strategy going forward. Because otherwise, you will not grow the pie, neither for yourself nor for everybody else, because people will stay on their local system and will just build their local systems better, especially now with the argument around compute sovereignty. Like with COVID, it has taught us that we do need to work together globally, but it also has shown that the global connections can break down quite easily. And therefore, you do need to have some sort of self sufficiency. And that really fuels the argument for saying, well, we need to have local compute resources. We do need to have local high performance compute facilities where governments put in the money in order to ensure that. And this goes basically against the argument of the cloud and multi-vendor and sort of having a globally connected world. So I think there's this balance between what the world is currently showing us and what examples are out there. And together, I think we need to build more examples out there that show that you can have self-sovereignty, but also the connectivity between the rest of the world, because those data sets that are located around the world are absolutely crucial to informing the analysis that you do locally.
Yeah, that's super well said. And this is often something that comes up around the multi-cloud, cloud lock-in, vendor lock-in, and it definitely seems like the argument for vendor lock-in being less of a concern on like the purely the web application development or mobile application development is you're building a product, and so your focus is on the product and making that a scalable solution on multiple different clouds is almost delays getting that customer feedback and then iterating on the product due to the global scale of some of the offerings from like AWS, GCP, et cetera. But when you start talking about this specifically, I can definitely see how it's a much more broad conversation. And if there are arguments on that side for the need for that, then yeah, I completely agree. The cloud providers need to hear that, need to continue to make that part of their strategy, because we definitely don't want people to say, yeah, it's about 85% what I need and it'll be awesome, but it's missing this one core element strictly because of, as you mentioned, they're not trying to grow everybody's pie. They're trying to kind of lock things down underneath their specific umbrella. And that's where we get into situations, which I'm sure you've ran into, where GCP might have one service that's way better than Amazon's service, but then the ability to use these two things seamlessly between the two becomes really difficult and a very complex problem. And I'm sure you run into those conversations of why are we using this at all? And so, yeah, completely makes sense. And one thing that I have written down here as well, which I want to make sure that we talk about, is you're a AWS Data Hero, which is amazing, and you were also Australia's first AWS Data Hero. What did that kind of look like, and what did that mean to you to kind of be kind of held up by the community a little bit?
Yeah, it's, as I said, I came from the outside, and therefore this is sort of the validation that what we're doing is not completely crazy. It is actually something that is on a world level, and I think that confirmation to hear that from your own community is really rewarding, and sort of spurs you on to do better and deliver more in the future. So that was great. For me, being in this unique position, because I'm actually the only one out of the AWS heroes globally that is working in academia outside of the IT space. And therefore, for me, I sort of feel that I'm sort of the ambassador for that space, for to bring the problems of that space to the IT community, and sort of implore everyone that there's so many problems in that space and so many opportunities to solve medical research and bring that forward, that I think everyone who has a bit of spare time and interest could really make a contribution there. And that's what I'm trying to bridge, this gap between medical science academia and the IT community. Because as I said before, all the fantastic work that the IT community is doing needs to flow into the medical science space. And it currently is not really, because the medical researchers, they're not IT experts typically. And therefore, there is this idea that sometimes you can hack things together, and solutions that are good enough are good enough, rather than really striving for the latest, newest, embracing the good software practices, high standards around that. And so therefore, there's this whole opportunity of bringing that good practice, that solid track record of how to develop software more rapidly, more stable, how to bring that into the medical community. So, for example, there's an FDA paper around machine learning as medical devices, where the question is, how do we train machine learning methods to be robust? Or on the flip side, how do we detect whether there is a prediction that is for an individual not optimally? And how do we identify that before it ends up in a catastrophic outcome, for example, death? And all of these questions, like, they do exist in the IT space already, probably not quite as, on those stakes. I don't know, maybe they do in the air travel community or so. But I feel that there's a lot of knowledge over there that can be brought into the medical space.
Yeah, and this is really interesting because as you were talking, I was thinking, where would we start with that, right? So would that be like tools, or I think I put here like practices that are then funneling down to existing people in the space, or is it more even during the you said academia, is it during these kind of degree programs where people are learning about this stuff in their college journey, where is it being covered enough, kind of the more modern practices that you're implementing here, coming from the background that you have going through school and that going through that background, sorry. um, where would we attack this problem to kind of bring in these new modern IT practices for maybe new professionals or existing professionals in the space?
Yeah, I think it needs to come in quite early, at least the notion of it. So looking at my own education, like, we were trained in software practices, and it was sort of drilled into that this is the foundation of anything, of all the cornerstone of how robust your research is going forward. And I think that understanding and that realization needs to come in quite early, because if you don't have that, and if you realize that in practice you can get away with quite a lot, then it's already too late. Sort of, it's hard to reform people, rather than teaching them good practices from the start. In saying that, though, when we look at the cloud, like, the cloud wasn't around way back when I did my education, and similarly, it only just flows into the IT education today. Right, there are cloud courses, and it's sort of this special thing that is happening at universities. And yet people have adopted the cloud quite ferociously. So I think it's never really too late to adopt good software practices and develop good software practices. I think with an even more connected world, and this notion of modularity in the core of your architecture, serverless, right? There is this paradigm shift of how do we treat interoperability, how do we treat version control, how do we treat continuous deployment. Like, all of these are new concepts that I don't think have quite settled down yet. There's still development in that space, and I would probably argue that it is ongoing development, forever.
Yeah, absolutely. Yeah, so that makes a ton of sense, that you would, now we're actually starting to see that. So definitely keep doing more of that, add more into the curriculums to include cloud, modern development practices. It's really cool to hear that you were already drilled in with the software practices going through the field that you're doing. And so when it comes to that, what does your day to day look like in terms of, you mentioned version control, CI/CD, these different areas? Is that, if you had to give like a percentage about how much your day is spent in different areas, how would you define those kind of buckets?
Right. In terms of good software practices, I think we're still very much on the research side. Like, we're not quite code cowboys. I think we evolved from there, but I don't think we fully embraced the how the beautiful software development pipeline that we could be doing. Like, for example, in my vision, it will be that software development is done in the cloud, and therefore you can bring in the latest, newest code analysis tools that automatically go over your code, annotate, where you could improve the syntax, where you could improve the performance, where your for loop has some elements in there that do not need to be in there, etc., etc., right? And similarly around the security protocols, right? It could automatically flag that you could be encrypting the data here and decrypting it over there in order to boost up your overall penetrance, if you want, of your solution. So with all of that, it could be in the cloud, and it could be this seamless thing that we then press a button and it gets deployed to either one of those cloud providers. And all of that is in theory possible, but we're not really doing it because there is no one thing, like one software solution that offers all of that. It would require a lot of work on our side in order to make this happening. And then there's the question, well, with research being so flexible, how much can you actually afford to put into these good, solid pipeline practices before you're going overboard in logging yourself down in terms of the innovation and the speed of update and so on? That is sort of the balance specific to the research space that you need to find solutions for.
No, that's a really interesting answer. So I think one thing there too is when it comes to abstractions and the when we talk about serverless, and if you open the Lambda console or anything like that, the amount of options, the complexity, and as you said, it's maturing, and so there's things that are old that no longer are the best practice, and it's constantly evolving. And when somebody comes into the space, they can sometimes be overwhelmed by the number of things going on. Do you feel like there's a necessary abstraction that needs to happen over just going into something like AWS or GCP alone and trying to interact with these services? Would the medical science field have their own abstracted version of of the cloud that they can then run, their specific tests and all these things on without, with doing some automation in the background, of course, and just make that easier? Or do you feel that at some point everybody's going to need to develop some of these cloud computing practices themselves?
That is a very good question. Yes. So abstraction obviously help with adoption. The easier it is, the more people adopt it. But it also has the problem of you can't really build what you need to build. I think this is sort of the huge difference between AWS and all the other cloud providers, in that AWS is this open sandbox where you can really, if you wanted to, drill into the lowest level and build something from scratch there that other cloud providers might not allow you to do. So this is, again, good and bad. And for us, it really allows us to build something truly novel, and an architecture that is not based on a template. And for our application cases, that is that is absolutely required. But it also means that we do need to think about how do we do the architecture, where does it fall down, where are the vulnerabilities, and so on. And probably we miss a lot of things that could be optimized, that could be made better, that could be more robust. And therefore the abstraction would help with that. So yeah, it's sort of this spectrum. It's good to have both. I would argue that you're starting to build prototypes on the absolute lowest level, but as you mature and bring it into production levels, especially in health, where it's critical that it gets it right the first time, the abstraction levels help with coming up with robust solutions that do not have any security flaws and so on.
Yeah, I completely agree. It's a hard line to navigate because we've often ran into things, and I've ran into this in my career as well, where we use some tool and then it's a black box, and then you need to do something outside of it, and you run into these issues, and then you now have to start over from scratch, and that can always be very discouraging, to say the least. And so yeah, so the idea that AWS is a little bit more low level, allows you to kind of create what you need to create and go as far as you need to go, versus more of fully managed black box services at some level. Yeah, that's a really great way to say that. And so yeah, coming to a close almost, I wanted to pick your brain a little bit about the role that open source. You mentioned it earlier as well, about the role that open source has played for you personally, and also what you believe open source plays for the entire community.
I'm a big believer that open source is sort of, the thing that everybody should be doing. But then again, I'm an idealistic researcher. So for us, what we do is all of our tools are open source at their core, because this is where we get the credibility from. This is where we get to publish, get the peer reviewed, um, evaluation of what we're doing is correct and is the highest standard. So I think that is sort of absolutely crucial to our software development practices going forward. But then we also, because we do need to get money in order to fund all that development going forward. And for that, I think we adopted this software 2.0, open source 2.0 paradigm, where the core is open source, but then the surrounding services are where the commercial value is. So for us specifically, the deployment of this open source is where we're trying to get our revenue in that funds the research that we do. So we developed a cloud solution that has gone onto the AWS marketplace. In fact, it was the first health product from a public sector organization to go on a digital marketplace. And this, I think, allows us to keep on developing the open source core, publish that so that everybody knows what is inside and how it's working, and being able to benchmark it to other tools. But then have the deployment of how to stand up that solution in someone else's cloud account, how to make it talk to the data, how to have the security standards around that, have this as sort of the paid service around it. And so for us, this has two benefits. One is that it enables reproducible research. That is basically the foundation of medical research, that you do something, you find something, and then someone else that is unrelated to you replicates that finding on a different data set. That is sort of the gold standard. And typically that is quite difficult because it's so hard to replicate exactly the same environment with exactly the same workflow somewhere else. Like there's always something different. The hardware is different, the libraries are different, the way you run it, which one you run first, etc. All of this can be different. And I think with the marketplace, that is sort of the first time where we say, this is the solution, replicate it over here, press this button, and it either works, confirming that the research is correct, or it doesn't work, which means there's something wrong with the research rather than the architecture that you've set up over there. So reproducible research is a big thing in the community, and marketplace really allows for that. But it also allows us the traditional meaning of the marketplace, namely to get in revenue through paid services of how to deploy it easier and simpler. So I would hope that in the serverless community, there is something similar set up soon. I do know that there is the app library, for example, AWS, which allows individual Lambda functions to be registered with basically a marketplace. But you cannot commercialize that, like you cannot attach revenue to it. And it is just the Lambda function rather than, I think, the whole architecture around it. So there is, from my perspective, there's this urgent need for a marketplace of serverless architectures where each one of those services that they're using, they're metered and billed so that the client, again, has the benefit of serverless, that they only pay for what they use rather than a standard set a boxed fee.
No, that's very inspiring, actually. And I hope that people listening take that to heart, because it definitely seems like something that we need to get rolling. And if we could, then I think that opens the door to tons of amazing possibilities where people will be building things out and then being able to basically market them to do exactly what you're describing there, and ultimately hitting revenue as well. And so it was also very cool to hear about the open source side of things where you'll have that code kind of publicly there. People can actually see that. And then that's something also that's happening in the blockchain, like in the decentralized finance space as well. Very heavy open source usage. And it's almost, it's a different model. I think that's probably why it's so exciting, is that it's almost a different model than we've seen in the past, where things are usually like kept underneath private, and now you have this, you have decentralized finance, you have other communities that are now building out entire products publicly, and then it's not stopping them from being able to achieve their end goal, but they're able to actually do things like bounties, like code bounties, where people can add code and then actually get paid for contributing code without having to have a normal contractor employment, NDA, all these things. And so I think that whole space is very interesting to watch. And I really appreciate you giving insight on that. As we're coming to a close, something that I always like to do with guests that come on is ask if you have anything that you want to promote, either personally or with your work, so that people can kind of learn more about you or find other things that you'll be presenting at or talking about, or your own blog. So do you have anything that you want to kind of promote?
Yeah, sure. So our research, as you were saying so nicely, like the age where you develop something as a core team that doesn't change and get paid for it through a contract, I think that age is over. It is the contribution of the community, like democratization of the code base. That is where we're going to, and it's the same thing with research. So therefore, I would strongly encourage everyone who finds this interesting and wants to dip their toes into this and see if there's anything that they can do, to go to our webpage. We do have tons of developments there. So from machine learning, of developing or finding disease genes, to the search engine of the genome, where we can help edit the genome in a safe way, to then advanced therapeutics, combating antimicrobial resistance, which is a problem that is way larger than COVID ever will be. So all of these areas desperately need the input from IT experts. And therefore, if you have time spare and have an expertise to contribute, have a look at those code bases and see if there's anything in the GitHub repository that you can pick up, contribute to it, submit, and then have contributed, to research, to saving lives in the future. Isn't that awesome?
That is absolutely awesome. So fantastic, and thanks again for being a guest on the Talking Serverless podcast. It was great to have you on, Deniss.
My pleasure. It was great talking to you.
To those listening, this has been the Talking Serverless podcast with Ryan Jones. If you like our show and want to learn more, definitely check out talkingserverless.io. And of course, please leave us a review on iTunes, Google Podcasts, or Spotify. And join us next time as we sit down with another fantastic guest.